All right, so I figured it'd be helpful for you guys for me to finish the notes that we didn't get to finish yesterday in class, just so that you have a couple of more examples to work from on your homework. So we'll look at the third graph, the f of x equal to -1/2 times the absolute value of x plus 1 minus 2. So here our a value is -1/2. Our h value, again, be careful here. This is really x minus a -1. So our h is -1, and then our k is going to be a -2. So our parent table of values, I'll go ahead and fill in the x values, -2, -1, 0, 1, and 2. The y values 2, 1, 0, 1, and 2. Again, that's the same parent table that we filled out a bunch of times in class. And then with the x values, since my h is negative, I'm going to go ahead and subtract 1. So this number should match what you're putting here. And then again, I'm going to start with my x value over here in my parent table of -2. I'm going to subtract 1 from it, so I end up with a new x value of -3. And I'm going to go down the line here. -1 minus 1, -2. x1, 0 minus 1, -1. Then 1 minus 1, that'll give me a 0. And 2 minus 1 will give me a 1. So now we said that the a value and the k value both transform y. The a gets multiplied first, and then the k either gets added or subtracted. So I'm going to go ahead and multiply all of my y values by 1 or -1/2, because that's what our a value is here. So when I'm talking about the y values, I'm talking about these parent table y values. So 2 times -1/2 gives me a -1. 1 times -1/2 gives me a -1/2. 0 times -1/2 gives me a 0. 1 times -1/2 gives me a -1/2. And then 2 times -1/2 gives me a -1. And then what I need to do, since k here is negative, I'm going to take all of these values that I just calculated, and I'm going to subtract 2 from all of them. So -1 minus 2 gives me a -3. -1/2 minus 2 gives me a -2.5. I'll write that as -2.5. 0 minus 2 gives me a -2. -1/2 minus 2 gives me a -2.5. And then -1 minus 2 gives me a -3. So when you're doing your actual graphing, your x values are going to come from this x column over here, and your y values are going to come from the numbers that we just calculated. So the ordered pairs here end up as -3, -3, -2, comma, -2.5, -1, comma, -2, 0, -2.5, and then 1, -3. And I'm going to go ahead and graph these on my coordinate plane. 1, 2, 3. Branch is a little bit off there, but this is what your graph should basically look like. And again, don't forget to put the little arrows at the ends of your arms or your branches. So then we're going to answer a couple questions about this graph. And this one definitely looks different than the ones that we completed in class. So our vertex, we said, was at h comma k, which we can confirm is going to be -1, -2. And again, that should match your h and your k value. This time our graph is opening down. So the wide part of the V is going downwards. The graph moved left, and it moved left 1 unit, and that was because of our h value. The graph shifted down, that was 2 units, and again, that was because of our k value. Here, our graph actually ends up having a vertical shrink. So we were kind of talking about the vertical stretch versus the vertical shrink. You can see that this graph almost looks a little bit wider or a little bit flatter than the parent graph. And I'm going to say that it has a vertical shrink. I'm just going to say by a factor of 1/2. And that factor is coming from, oops, I should say of. That factor of 1/2 is coming from the a value. So we know that our a value is -1/2, but since the negative is what reflected it, we would just say it's a factor of 1/2. So the slope of the right branch here is actually going to be -1/2, and you can count that, or you should be able to look and see that that is your a value as well. And then our domain here is all real numbers, so negative infinity to positive infinity with the interval notation, or in set notation, that is just x such that x is the element of real numbers. Our range, we're pointing downwards, so our range is actually starting from negative infinity and we're going up to -2. So our range, negative infinity, comma, -2, then -2 is included. So I'm going to use a bracket. Or in set notation, that would be y such that y is an element of the reals. And we're saying that y is less than or equal to -2. It's less than because we're starting at -2 and we're taking any value that's lower than that or less than that. So hopefully this helps just see kind of one more example when we had an a value that was negative and a fraction, and kind of see how that differed from what we did in class. So I would like to just kind of quickly go through these types of questions on the back, because you're going to have some of these to try in your homework as well. So I'll go through just one of these questions and then I'll do the two at the bottom. So for each of these functions, you want to explain the horizontal and vertical transformations, identify the slope of each branch, identify the vertex. So the first thing I'm going to do is I'm going to go ahead and label my A, H, and K, even though it's not asking me to do that. I like to do that just so I know what's what. So my A value here is -2. H would be +3. Again, it's going to be opposite of what you really want it to be in there. And then the K is going to be +4. So I'm going to start with the vertex here. So here my vertex is always going to be H comma K. So even without looking at the graph, I know that my vertex is happening at the point 3 comma 4. And you always want to write your vertex as a point. And then I'm going to write my horizontal translation, meaning which way is it moving, left or right, and how many units. So I know since my H value is 3, I'm moving right because the H value is positive. And I'm going to say 3 units because the H value is 3. So H is +3, so the graph is shifting right 3 units. My vertical translation is going to be from my K value. And since K is positive, my graph should be shifting up. So I'm going to say it shifts up 4 units. And then it is also asking me to identify the slope. But before I do that, I'm going to also talk about 2 things with the A value. So since the A value is negative, this is reflected. And I'm going to say specifically over the x-axis. And that is because the A value is negative. And I'm going to say that this one is actually containing a vertical stretch. And I'm going to say by a factor of the A value. And I'm just using the 2 here because the negative has to do with the reflection. And I'm saying that this is a vertical stretch because this number, the absolute value of your A value, is going to be more than 1. So the absolute value of A, when it's more than 1, creates a vertical stretch. And then my slopes, I'm actually just going to worry about my right branch, because we know that the right branch has to do with the A value. So the slope of my right branch should actually be -2 here. And again, that's coming from the A. So these last 3 things, the reflection, the vertical stretch or shrink, and the slope, all have to do with the A value. So then I want to just quickly talk about examples 2 and 3, because this is actually going to be kind of almost doing the opposite of what we did here. I'm giving you this information, and what I want you to do is I want you to write an equation that looks something like this. So remember that our standard form is f of x is equal to a times the absolute value of x minus h plus k. So here, I'm going to go ahead and I'm going to identify the different pieces so that I can go ahead and plug them in here afterwards. So a vertical shrink by a factor of 1/4. That's telling me anytime I'm talking about a stretch or a shrink, that's talking about the A value. So this is telling me that my A value is actually 1/4. A vertical translation 1 unit up. So if I'm moving up or down, that's talking about the K value. And since we're moving upwards, K is going to be +1. And then it's telling me I'm going to have a horizontal translation 3 units to the left. So we know that a horizontal translation, left or right, has to do with the H value. And since I'm moving to the left, it's going to be a negative. So H is going to be -3 here. So when I put these 3 pieces of information in, I'm going to go ahead and substitute them where they go here. So I'm going to say f of x. You always want to do f of x or y equals. And I'm going to say 1/4, because that's where my A value goes, times the absolute value of x minus my H value of -3. and then I'm going to do my plus k of 1. And the only thing that I want to clean up here is I'd never want to leave this as a double negative. So I'm going to go ahead and just simplify that. So f of x is going to be equal to 1/4 times the absolute value of x plus 3, and then plus 1. And that would be my absolute value function after these transformations are happening. So we'll just go over one more quickly here. So we got some different pieces of information, same idea though. So here we're reflecting across the x-axis. So we were talking about that in the last problem. So this is telling us that the a value here is negative. I'm containing a vertical stretch by a factor of 4. So stretch or shrink again has to do with the a value. So that must mean that my a value is equal to 4. Horizontal translation 6 units to the right. So again, horizontal translation right, that's telling me about my h value. Since it is moving to the right, it's going to be positive 6. And then the k, vertical translation, because we're moving it down. So if we're moving down, k is negative. So k is negative 3. So again, when I kind of look back at my standard form of my function, I'm going to go ahead and just kind of put things where they need to be. So f of x is going to be equal to, my a value is a negative 4. So negative 4 times the absolute value of, I'm going to put x minus my h value of 6, close my absolute value bracket here, and then I'm going to subtract my 3 at the end because my k value is negative. So here we don't have to do any simplification. We don't have to do any cleaning up. This is going to be my final function. I hope that's helpful. Please let me know if you have any questions.